Okay, so I said that we talk a little bit more about the reading guide and the syllabus. So our textbook is this guy. Okay, it's available for $50 in the bookstore. And I highly, highly encourage you to print off a physical copy of the syllabus. That's totally unreadable. Hello, welcome, 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 greetings. So this is our list of what happens when. Okay. I encourage you to take this, put it in your book, and sort of keep track of where we are as the course goes on. You know, right now we are in week 1. And we're going to be looking at parametric equations, calculus with parametric equations, this kind of thing. Okay. Our tasks for the week are to relax and breathe. Okay. The rest of the time we have many, many things to do. Okay. We've got quizzes, tests, all sorts of stuff. Right, so get a copy of this, put it in a prominent place. The other document that I encourage you to print off is the reading guide. Okay. Okay, yes, very good. So what this reading guide does is it lists all of the recommended exercises for the whole course. Okay. Our textbook has hundreds and hundreds of problems in it. So this tells you which problems to look at in specific, and which sort of examples to read. So I want to take a moment and go through what this document's saying to do for this week, and then we'll look at a little bit of math. Okay, so it says that we should do these exercises and read 1.1 and 2. Okay, so let's go and find those in the thing. Okay, so we go to the very beginning of our book, Parametric Equations. We go to section 1.1, okay? And then the reading guide will tell us what to do with this stuff, okay? So, oh, okay, this is much harder to balance than expected. Okay, so it says read 1.1. Okay, so we want to read example 1.1 and get a handle on what that's saying. Okay. Example 1.1 matters to us a lot. Okay. Same thing with 1.2. Okay. It says read 1.2. This matters to us. And then it says read cycloids. Okay, so we want to look at cycloids. Oh geez, I broke it. Okay, so we've got the stuff we need to read, 1.1 and 1.2 in cycloids, and now to the exercises. Okay, so we go to the end of the chapter. Okay, and it's saying do 1, 2, 3, 4, 5. Okay, 26 and 49. Where did it go? Okay, so what this does is it tells us all the duties that we need to do to get ready for our quizzes. Okay? Every tutorial we're going to have a quiz, and these will be sort of simple, very direct things that we need to do. So we've got the following questions to get us ready for our quiz. Okay, so I encourage you to go and do these things. All right, so what's this first exercise say? For the following exercises, sketch the curves below by eliminating the parameter t. Give the orientation of the curve. What? What on earth does this mean? We haven't talked about any of this stuff. Just talked about the syllabus. So what I would encourage you to do at this point is to go back and look at those recommended reading things. Okay, so to go and to look at what the readings are telling you. The readings will have examples that get you ready to solve the problems. Aha! Eliminating the parameter. That's a thing we have to do. Okay, so this is how we can use the textbook, we can use the reading guide to figure out what we need to do for this. What's 1.1 saying? You have to graph the curve. Aha. Okay, so we'll get into what these things mean and then we'll try and solve that exercise. So the first thing that we need to know is what are parametric equations, right? This whole thing is about parametric equations. Okay, when I write this fancy squiggly thing, it means section of the book. And this symbol means section. So we write an S, and then another S. So we need to understand what parametric equations are. We need some kind of a definition. Parametric equation. Folks in the back, can you see the blue okay? Sorry, yeah, we got it. When I write things in all capitals, special color, that means this is a new definition, something that we haven't seen before. So a parametric equation is a curve given by coordinates x of t and y of t. Okay, so the idea is we plug in a value for t, and we get a coordinate in the plane somewhere. Often I find that examples make things much clearer, so we'll do an example of this. So our left-hand side is x's and y's, and our right-hand side is functions of t. People came up with parametric equations by imagining t to be time. That as time went on, you'd have a point that moved around. Right? Like if you imagine the position of your phone as a function of time, it moves around the planet, and that gives you some x and y position. Well, let's sketch this particular curve. Okay, so we'll do it like in grade 9, where we make a table of values. Okay, so we'll put in various inputs t, get various outputs x, y. Okay, so we let our t be the values 0, 1, or 2. Now our outputs will be points. What are the steps here? We take our value of t, we plug it in, so we get t is 1, so we get 1. T is 1, so we get 2 times 1, plus 1 is 3. Okay, so we get a point somewhere in the plane. Okay. And we make our coordinate axes. And we plot the points we've obtained. Okay, so if t equals 0, we get 0, 1, so we put the point 0, 1. T equals 1, we put the point 1, 3. Okay, t equals 2, we put the point 2, 5. Now we've got a graph of the thing, and we can play kind of a connect the dots sort of theme. One thing about parametric equations is that they come with a notion of direction. As t increases, where does the curve go? Where does the phone travel? So we'll indicate that with little arrows. As t increases, we go here, here. Yes?
If you're sketching like circle,
Yeah?
like, do like the direction of arrows matter?
Yes. Yes, the direction of the arrows matters even if you're sketching a circle. Yeah. Yes. Good thing to check. Yeah, so the direction of the arrow is always, which direction is t increasing? Thoughts here, questions here? Observations so far? See like 3 people who are just bored to death. That's natural, that's okay. Okay, so our question, the question from our book, oh, hi, welcome, greetings. Our question from our book asked us to eliminate the parameter. So we have to figure out what that means. So we'll eliminate the parameter here.